So you are a DBA or a database professional working with outdated technology. You want to kind of feel relevant, right, with all new technology coming out. I created this session called Big Data Clusters for the Absolute Beginner. Again, the reason why is because I used to be that individual, right, that data professional sitting there in the cube working, and I'm reading about new technology coming out. It started to make me feel disheartened and deflated because the company I worked for wasn't adopting, and that's usually how it works, right? The adoption of the new technology is a lot slower than the rate at which it comes out, right? So there's an abstract for you. Are you a DB or database professional working with outdated technology, or feel your skills are quickly becoming irrelevant? Stay ahead in today's ever-changing tech space and take your career to the next level. So my name is Mohammad Darab. Thank you for watching. This is going to be specifically for YouTube. So I give this talk at SQL Saturdays, and I'm in front of an audience or a bunch of attendees. So this is going to be kind of a condensed version just for YouTube. So a little bit about myself. I'm from the DC area, close to 20 years in IT, a little over half of that working with SQL Server. I'm honored to be part of the IDERA ACE class of 2019, and all that means is whenever I go do speaking engagements, IDERA sponsors that. So big thanks to IDERA for that. Online, I'm very active on my blog, mohammaddarab.com, as you see right there. Very active. A lot of my recent posts have been all about big data clusters and, of course, preparation for these sessions. And on Twitter, you can feel free to reach out to me at MWDarab. So the agenda, we're going to be talking about a little bit about the history. What is a BDC in terms of the Microsoft definition? Architecture, so give you an overall view of the architecture. Then we're going to kind of dive in a little bit deeper into the components. Again, not too deep. This is for the absolute beginner, so no worries about that. We're going to talk about some of the features that the BDC offers, most thoughts from myself, why I'm excited, and why I believe you should be excited about this new technology, and a learning path. So if you look there at the bottom of the screen in the footer, you'll see mohammaddarab.com/BDC. You don't have to take notes or anything. You can visit that link and everything is there. We'll go over that at the end when we're talking about the learning path. So let's start off with the history. In 2016, SQL Server introduced something called Polybase, right? This was in addition to SQL Server. You can install this feature, and it allows you to combine non-relational and relational data. So if you're a relational database administrator, let's say like myself, I can now reach out and read Hadoop sources like on Cloudera or Hortonworks. At the time, those are the connectors they had that you can connect to those services and pull non-relational or big data, right? So you can sit from your SQL Server instance and now deal with some big data. At the time when it came out, I remember it had nothing to do with me. And usually when I give this talk, I ask people how many people have, installed and deal with Polybase. Not that many. So again, I understood it conceptually at the time, but it was a huge, didn't involve me, so I just moved on, really didn't look into it. Next year in 2017, they came out with support to run SQL Server on Linux, which is huge. At the time when I read about it, the first question I thought was, who would want to install SQL Server on Linux? Again, also when I asked this question to people, who has installed SQL Server on Linux, very few hands go up. So I just didn't connect the dots yet. So there was a big still question mark of why, like why would Microsoft dump money into making SQL Server run on Linux? As a result of it running on Linux, you can also use Linux technology like containers. Docker over there, you see the image right there of the little whale. Docker is a company, and it's the quote-unquote big kahuna in the container market. So now you can run SQL Server, a container of SQL Server, on the Docker engine running on Linux. The following year, the year that I'm recording this, at least 2019, now they have this Polybase, but it's called Enhanced Polybase, right? And just to kind of sum it up, right here where they have the big data on the lower right hand corner of this image, they had the Cloudera, they had the Hortonworks, but they also added Apache Spark connectors. And now on the relational side, you can actually connect to an Oracle server, which is actually very, very huge and a big deal. And get your data from an Oracle server, right? Select the data, and now you have that data from the Oracle server on your SQL server, right? Teradata, then NoSQL, you have MongoDB, Azure Cosmos DB, and then also your ODBC connections like IBM DB2, SAP HANA, and Excel. They've also introduced the option to deploy an availability group or an AG on a Kubernetes cluster, right? So that was kind of huge. So now, this being said, let's kind of clarify some possible questions that you all may have, starting with Polybase versus link servers, right? So I personally do not like link servers. I always find them to be cumbersome, or whenever I've been in situations where link servers are being used, it's absolutely against what it was meant to do, right? So there's so much errors and troubleshooting stuff you got to do because, again, they're being used for what they're not meant to. So very quickly, you can see on the left side, Polybase database scoped, right? On the right side, link servers are instance scoped, right? Polybase supports read-only operations for all data sources and insert operations for Hadoop and data pool sources. We'll talk about data pool sources in a minute. You don't need a separate config needed for an AG if you have an availability group and you have Polybase. You don't have to separately configure and install it on each instance. Suitable for analytic queries, processing a large number of rows for Polybase. On over to the link server side, supports both read and write operations, right? Separate config is needed for each instance in an AG or an availability group, and is suitable for OLTP queries returning single or few rows. So whenever I've dealt with link servers, they're on like data warehouses and they're doing massive amounts of data set results and returning huge rows of data, and it just I just don't have a huge taste for link servers. So that's the difference between Polybase and link servers. Containers now. I mentioned that briefly that in 2017, now you can install SQL Server on a container. So a container, if you're not familiar with it, a lot of people have heard the term Docker container, the word Docker or Docker container. Docker, it's a company, right? The name of the company is called Docker, if you see down here, and their little logo is a whale. Now, the Docker container or the Docker engine, right, is a product that Docker offers, and you install it on your machine, on your host machine. And then using the Docker engine, you can, quote unquote, instantiate these images into containers. So a container, imagine it as, and I mean, the word befits what it is. It's literally a container, a virtual container, and everything inside that container or all the files that are within the container are needed to run that application, right? And then you can take that container and move it anywhere, right? So as long as you have the Docker engine running, it'll run. You don't need to worry about, oh, this ran on Windows Server 2016, but now in 2012 it's not compatible, this and that. As long as everything it needs runs on that container, you're good to go. So it makes DevOps and things like that a lot quicker, a lot faster, and that's mainly what it's for. And again, when you think about a SQL Server, right, a database instance or a database server, and you have production data on it, you really want to make sure that you know your ins and outs of how to operate that service, right, that server. So you don't want, so a lot of people, they don't use SQL Server on a container on production. It's mainly for dev and test. So if a developer comes up to you and says, hey, and you're a DBA, developer comes up to you and says, hey, I just need an instance of SQL Server. I need to play around with this query or this or that. You can instantiate that real quick, and when they're done, destroy it. Done, right? You don't need to download the ISO, install it, go to the GUI, wait through all of this and patch it, this and that. You don't need to do that. It's a lot faster with containers. Again, if you're absolutely new to containers, do not worry. The learning path, I have a bunch of links and stuff to help you out. So this is just conceptually understanding what it does. So now Kubernetes, and almost everybody's probably heard of Kubernetes and seen this ship wheel, right? Logo of theirs. It's a container orchestrator. So when you have containers, let's say in this case Docker containers, you need an orchestrator, like a quote unquote brain, to scale these out, right? Scale the resources out, scale them back in, right? If one fails, to create another one, and you need this type of brain to, like, again, quote unquote, orchestrate this whole container business. And that's what Kubernetes is for. But everything Kubernetes does is within the context of a cluster, or a Kubernetes cluster, right? If you look at here in the middle of the image on the right, you see the master node, right? And then you see these other nodes around it. These are called the worker nodes. So you have the master node in the cluster that's in charge of the cluster, like the brains behind the cluster, in charge of distributing work to the worker nodes, the cluster health. Everything is done by the master node here. The rest are worker nodes. They actually do the work. Now, when I say node, a node runs the containerized application, but a node can be a physical machine or a VM. So if you create, let's say, 4 VMs, right? You have one being the master, right? And then you have 3 other VMs are the worker nodes, right? So that's your 4-node cluster, right? And a pod, if you've heard of the term pod, if not, don't worry. These are still terms that we're all getting used to, and I'm even learning. It takes some time. Is a logical group of one or more containers and associated resources. So Kubernetes will take your container and put it on a pod, right? And a pod is Kubernetes' smallest unit of computing, right? Of what it handles with. So it'll take that container that's running whatever, let's say SQL Server, and put it on a pod and then control it. Put that pod on a node. So a pod runs on a node, and a node can run one or more pods. Might be confusing as hell, and no problem. So in order to lessen the confusion, especially for myself, because sometimes I'm a visual person. So I learn through visuals, right? And I actually drew something out. So hopefully this will help you out, but the next slide is what I drew out. So if you start at the left side here, the image, right, is, let's say, the SQL Server image, right, the ISO file, right? They create an image that has everything you need to run SQL Server. You download that, and once you start it and run it, it becomes a container, right? It becomes this container. Now, you take this container, and this container goes on a pod, right, in this pod. Now, you can have multiple containers. You can have a container here, a container there, this container running SQL Server, this running some other service, and you have multiple containers on a pod, right? Oop. And then the pod will get put onto the node, which is that physical machine or that VM that I mentioned, and then that will be part of the entire cluster, right? So hopefully that kind of sheds light on the hierarchy, quote unquote, of the Docker image that you download, and then the end, which is the Kubernetes cluster. So all of this, and why, right? The question is why? Why does Microsoft do this, right? I want to share with you some statistics that when I came across, as they say, your mouth drops, right? My jaw dropped to the floor. I want you all to also take a look at this, and maybe y'all have heard it before, or read it before, but this was new when I was actually putting this presentation together. Here we go. So data never sleeps. 90% of all data today was generated in the last 2 years, right? Very, very interesting if you think about it. 90% of all data out there on the internet, just out there, has been generated over the past 2 years. And I usually ask everybody in the session, I just ask them a blanket question. I say, what do you think the majority of this 90% of data is? What is it, right? And people usually say it's social media, and that's what it is, right? It's social media. It's people that are posting their thoughts every second, and all this information has to be stored someplace, right? So I want to share another piece of information with you that actually blew my mind again, and it's about Walmart. So read that for a second. Walmart collects 2.5 petabytes of data from 1 million customers every hour. 2.5 petabytes every hour. Billions of Facebook messages, tweets, YouTube videos. I mean, this goes on. This is Pinterest, comments, blog posts, Yelp reviews, everything and anything. They do it. They collect it. Walmart does. This is just Walmart, mind you. This isn't Target, Amazon, all everybody else. This is just Walmart, right? So you might be wondering, what do they need all this information for, right? I mean, not even information, this data. What do you need all this data for? Here's a little quote from a Walmart CEO back in 2013. We want to know what every product in the world is. We want to know who every person in the world is, and we want to have the ability to connect them together in a transaction. That's kind of, I don't know, there's a little sinister, you get like kind of goosebumps. I envision like Dr. Evil, right, from like Austin Powers, But that's what they want to do, right? So then how do they do that, right? By collecting all this big data. They want to make sure that when you walk into a Walmart, your phone goes off, right? You get a text or some email saying, oh, you're here on this particular day of this particular month, and this is the time and the weather. So most likely, based on all the stuff they gathered from you the past, n number of times you went, you might be on the market for some cough syrup because it's winter time and it's, whatever, like 8 p.m. or whatever. And they send you a coupon for cough syrup, it's just unbelievable the type of information that they can get from this big data. So now, what does this have to do with SQL Server and big data clusters? And just like we all want to be relevant, and we're all here to we want to remain relevant in 2, 3, 5, 10 years from now, so does SQL Server. SQL Server is saying, pick me, right? I've spent the summer practicing my 3-point shot, and I'm good. Pick me, right? The past 25 years, I've been a relational database engine, but now I can process it all. I can do it all under the umbrella of a big data cluster. So what is a BDC, right? According to Microsoft, a BDC allows you to deploy scalable clusters of SQL Server, Spark, and HDFS containers running on Kubernetes. These components are running side by side to enable you to read, write, and process big data from T-SQL or Spark, allowing you to easily combine and analyze your high-value relational data with your high-volume big data. That's pretty much the Microsoft definition. Let's look at, in terms of a platform and an image, because again, I like to have images, right, to kind of put it together. If you start on the left side right here, right, you have your unstructured and unstructured different types of data coming in. You got your high value structured data, relational data coming in. However way you ingest it, right? You store it. We're going to be talking about these components here in a minute. You prep and train it, and then you model and serve it, and that's where your BI tools and predictive apps come in. So let's kind of break each one of these down. So when you ingest it, data can be ingested by either Spark streaming, by inserting directly into HDFS, or directly into SQL Server just using your regular T-SQL queries, right? It can be stored in files in HDFS or partitioned and stored in data pools. We'll talk about what a data pool is. Stored in SQL Server master instance. Again, we'll talk about the master instance, and tables, graphs, or JSON. These are where all the smart people come in, and the data scientists, right? The data analysts, they come in here. They do the preparation of jobs and predictive analysis and machine learning, stuff like that, using Java, Python, R. And mind you, all within the confines of a big data cluster in SQL Server. Then they use a predict function and store procedure SQL Server master instance, or batch scoring over data in HDFS using Spark, right? So let's talk about the architecture real quick. Now this is an overview. This image was taken from Microsoft. What I did to this image was I just bolded the black here, so it kind of stands out. I got the black right here. The kind of light greenish, I also put that around there to bring out this light green. Everything within this is the BDC, or the big data cluster. And these red right here are Kubernetes pods, right? So, by the way, this controller, this is a controller right here. This big black rectangle that's kind of outside of this container, this green cluster, is inside, should be inside the cluster. I did reach out to Microsoft to ask them why is it kind of out of there, and they said the space issue, whatever, in their design. So not a big deal, but it is part of the cluster, so it should be inside the cluster, right? So let's break each one of these pools down, and we'll start with the controller. So the controller hosts the core logic of deploying and managing a big data cluster. So when you deploy a big data cluster, you actually deploy it, the first thing that's built is the controller. then the controller takes care of everything else. It's kind of like, imagine you build a brain, and then the brain starts to build everything, every other piece of the body. The controller is also in charge of a cluster lifecycle, bootstrap, delete, update, manages the SQL Server master instance. Let's go back real quick here. If you notice here, the SQL Server master instance, this right here, is the only entry point that you worry about as a DBA or database professional, is this. All your custom apps, your BI tools, your analytic tools, they all get this endpoint and they come in. Every other thing in here is abstracted from. You don't need to worry about it. So let's go back to the... So again, as you see here, manages the SQL Server master instance, manages compute data and storage pools. We'll talk about that, and also the cluster security. So the master instance is the external accessible endpoint for the cluster. You can connect to it via Azure Data Studio or SSMS, right? Scale-out query management. That engine is inside the master instance. Also, machine learning services are added. Everything is handled in the master instance. So once you enable that on the master instance, you can execute Java, R, Python scripts using the store procedure sp execute external script. Compute pool. So a pool is a logical grouping of like services, right? So a pool is just a logical grouping, no big deal, right? Inside of it are different SQL Server instances that handle, and the sole purpose is to just do computational resource. That's it. It just, whenever there's some things that need to be computed, send it to the compute pool. So the master instance is kind of not under that duress, right? The pods in the compute pool are divided into SQL compute instances for distributed query, specifically Polybase. The main role, again, for the compute pool is to perform intermediate joins aggregations of multiple external tables. So when you fetch data from, let's say, an Oracle database and you need to do some aggregation or whatever, that anything that has to do with that is done in the compute pool. The data pool, right, is used for caching and persisting the data, right? So when you get this data, is persisted and cached in the data pool, so then you get faster retrieval. The storage pool consists of pods comprised of SQL Server on Linux, Spark and HDFS, and all the nodes, right, on the storage pool are part of an HDFS cluster. So now you have SQL Server, Spark Engine, you got the HDFS, all working hand in hand within the storage pool. This is, again, this is just one component, the storage pool, within the bigger confines of a big data cluster. Storage pool, data ingestion through Spark, data storage and HDFS. HDFS data is spread across the storage nodes in the BDC for persistency. Data access through HDFS and SQL Server endpoints. Again, using ADS, Azure Data Studio, or SSMS. So Kubernetes Storage. I remember when I first heard about Kubernetes and what it can do is like, I don't know, about 2 years ago, year and a half ago. And of course, I'm late to the game. I'm a DB. I really don't have much to do with DevOps and, containers and Kubernetes. But when I heard what Kubernetes can do, I was absolutely amazed. And I started to fall in love with it, just the idea of what it can do. So what happens is, if you have a pod, for example, and on the pod, you have a container running SQL Server, right? Now, if for some reason that pod fails, let's say something happens and it just crashes and it stops, you program Kubernetes to say, hey, I need to have 2 pods of SQL Server running at all times. And this is like, and Kubernetes is like in an infinite loop, checking and making sure the count of pods for SQL Server is 2. Is it 2? Yes, it's 2. Keep going. And it just keeps checking. And if that count drops to 1, for example, in this contrived example, then what Kubernetes does, it creates another pod immediately, right? Creates a SQL Server and everything that's on there and assigns it back to the node. So you always have that 2 count, right? So when I explained this to a mentor of mine, a friend of mine, dear friend of mine, mentor of mine, and again, he's also a DBA. He got me in the DBA world. And the first question he asked was, well, how does the storage work? Right? You can't just drop the storage, right? Just how storage works. And I didn't know that at the time. And I was like, damn, So I had to go do research and figure out what the hell, how does Kubernetes work with storage? So how it does is Kubernetes, think of it as, a bouncer at a club. I don't know if that's like the right analogy, but it's there and is making sure that when people come in, they are, they fit the dress code. If there's a ticket involved, they have a ticket, right? And then they can go in to the club, right? If you don't have the correct dress code, or you're gonna cause a problem, then you're not allowed to go in, right? So Kubernetes storage works with persistent volumes. So if you have EMC storage or NetApp or whatever storage that you have is presented as a volume, right, to the Kubernetes cluster, and that's called a PV, or persistent volume, right? So how you map an external storage onto Kubernetes cluster. Now, how the specific pod uses the PV, they use a PVC, right? A persistent volume claim. So it's kind of like a ticket. So the pod has to have this claim, and then it can claim the storage, right? So if it doesn't have that quote unquote ticket, then it can't access that storage. So as long as that pod has that PVC, it can get the PV, if that makes sense. So that's how Kubernetes storage works. Cluster endpoints. Let's talk about that real quick. There's 3 endpoints right here. If you look at the top, they're in this purple circle. AZ Data, or the command line tool to access a controller. You can use Azure Data Studio to connect to Spark and HDFS gateways. Applications, ODBC, everything else, you use your regular TDS connection to the SQL Server Master Instance. In this case, Azure Data Studio SSMS. I usually ask people how many people use Azure Data Studio. Not that many hands go up. I'm an SSMS guy. I've been using it forever, obviously, because it's been around forever, and I'm accustomed to it. I remember when I first installed Azure Data Studio, and I started it up. I looked at it. I'm like, I deleted it. It would look bare. I didn't know what to do. I was like, what is this? And I just removed it. But as I'm deploying these clusters, these BDCs, and doing, I'm starting to fall in love with Azure Data Studio more and more. So it's actually something that it takes some time to get used to. But once you're doing something that you need it to do, and you find it that it's easier to do, then you'll start picking it up. So let's go on each one of these. So the controller endpoint is a big data cluster management, right? So you're using AZ Data to actually use a command line tool, right, to do a lot of cluster big data or BDC management. The HDFS Spark Gateway, HTTP-based endpoint used for accessing services like Web HDFS. The master instance, again, the regular SQL Server endpoint, right? That's what you give your database tools and application connections. Features. Let's talk about features real quick. The biggest feature is data virtualization. That's what Microsoft calls it, data virtualization. And this is when you can get data from, let's say, your Oracle server, your Teradata, your Hadoop, your IBM DB2, whatever it is, you bring this back via Polybase to your master instance, and now you can connect to these different external tables. And this whole process is like the virtualization, quote unquote, of the data, right? So data virtualization is a huge thing. And this virtual data layer, also known as a data hub, right, allows you to query many sources, many different sources from a single interface, i.e. Azure Data Studio. So this is huge. I mean, this just data virtualization with Polybase in itself is huge. But within the context of a big data cluster, even bigger. Data lake, right? So you have all these different streams or different data sources that come in, right? You can store it in the storage pool, right? Again, from multiple sources. Use it later. I mean, it's just, you have a data lake within the big data cluster. Data Mart, right? So you have your data pools, right? And you have all these different sources coming in and caching data there. And then it's just unbelievable what you can do with this big data cluster. So most thoughts, and here's my thoughts, okay? Why you should be excited, why I'm excited. Because this is a one-stop shop, right? It's one-stop shop, meaning the whole concept of ETL, right? SSIS, for example, right? So if your manager comes to you and says, oh, we would like this new report or this new thing, whatever, and you have to go to this database and that database server. You got to go to Oracle, you got to go to MongoDB, you got to bring all this stuff back, combine it with some SQL Server data, and then print out a report or whatever. You can do all that without leaving your big data cluster, right? Using Polybase, using data virtualization. That's all you have to do, right? So it becomes this one-stop shop. If you're dealing with data scientists, you just give them the endpoint connections to get in and do your business. You don't have to go and get their laptop, be like, okay, what you got? Oh, you got that? Okay, put in a thumb drive, got to go put it. None of that. Just connect to the BDC and do all your job there. Do everything right there, right? Now, the BDC unique feature, the second bullet point down, is, and I cannot stress this enough, the unique thing is the data virtualization, is Polybase, is the ability to access all this different data from just your big data cluster. You don't have to create something else to get that. You're starting to move ETL process aside. You're doing everything within the confines of a big data cluster. This is absolutely unique. There are other features out there that you can create a big, a data lake or data bricks and this and that. But big data clusters brought all of it together, right, within this confines of a big data cluster. It's the most unique feature of BDC is data virtualization. Now, this is a huge opportunity to become relevant, and this is why I think you should be excited, because it's not only just learning a single feature of SQL Server, right? So it's not just like, I want to learn how to do always encrypted or whatever other feature that is specific to SQL Server, right? You are learning, or as we'll see in the learning path, you are learning not only that, you're starting to dive into Linux, you're starting to dive into containers, you're starting to dive into Kubernetes, right? You need to be excited about that, because now you have a path, right? You have a, you just follow this path, and at the end, you automatically shot up your relevancy by like 1,000 times, 10,000 times, right? And not only to SQL Server, but all this other technology, right? And one thing I want to stress, right? And people that I talk to are more, obviously for the past 25 years, SQL Server has been a Windows thing, right? But I'll tell you right now, in a few years, it won't matter. The underlying OS will not matter. If anything, it'll be more Linux-based. This whole thing of the OS and SQL Server is going to be OS agnostic. It won't even care. Windows, Linux, whatever, IoT device, don't care. Run SQL Server everywhere, right? So to become relevant in that game is a huge opportunity, and that's why I'm excited, and I believe you should be excited as well. But the learning curve is steep. That's the only thing, right? But the learning curve is not steep without a learning path, right? If the learning curve was steep and you don't have an idea, you don't have a type of pathway to approach it at and tackle it, then yes, it can be daunting, right? But I'm going to leave you with a learning path, and we're going to wrap this up with a call to action. So anybody, if you're watching this, I really do appreciate you taking the time. I really do feel this is it. Big data clusters is the future of SQL Server, period, right? So your call to action is go to mohammaddarab.com/BDC, as you probably saw in the footer. There you will find this session as a PDF uploaded. You can download it, look through it again. You'll find a curated list of big data cluster blog posts. So I have a 4-part series on how to deploy a big data cluster on AKS, Azure Kubernetes Service, right? You can look through that. Every other post I have up is going to be there at the /BDC. Excel checklist, learning path to BDC, itemizes the following topics: Linux, Docker containers, and Kubernetes. What I mean by that is I break it down so when you open up that Excel, you'll see a checklist. And in the checklist of each one of these topics, like Linux, you'll see a couple links. I have books. I have links to different sources, learning sources, resources that I use to get up to par a little bit. Am I a Linux guru? No, not at all. Am I a container guru or Kubernetes guru? No way. I'm still learning all of this. But I do have what I learned on that Excel sheet. And for somebody starting out, again, the absolute beginner, this is the way to do it. And at least the way I did it. And I'm sharing it with you. Go there, download the Excel. You can change it, modify it however you want. right? But there's a bunch of sources out there, free sources and also paid sources, right? Plural sites, some books that I've purchased that help me out, right? So you just go ahead, and I highly implore you, if you don't want to keep checking mohammaddarab.com/BDC, everybody's busy, they're not going to bookmark everything. I have a newsletter. Sign up on the newsletter, and every time the BDC post comes, it goes straight to your inbox. And then you can create a different folder, all the BDC stuff, and just go check it out later. So if you sign up for the newsletter, you get that content delivered straight to your inbox. You don't even have to go look, it comes to you. So then, again, thank you so much. Since this is a YouTube, you can leave a comment if you want, or just reach out if you want to give feedback, mohammaddarab.com/feedback. There's a form there if you care. If not, that's fine. You can reach me at mohammaddarab.com, on Twitter at MWDarab. I do appreciate your time. And again, I'm excited for BDCs, and I hope you are excited for BDCs. If you want to reach out and have like a one-on-one conversation, or in the comments, or Twitter, my blog, feel free to reach out. I'm more than happy to talk with you, and hopefully keep that fire burning and keep that motivation high. Thank you.